All right, we're looking at Coulombs Law. I made a little error in my first video, so I deleted it, but I wrote in Sharpie on my page, so here we go. Our equation for Coulombs Law is your electric force is equal to your Coulombs constant times charge 1 times charge 2 divided by your separation distance. This is very similar to the universal law of gravitation we learned about last semester. Relating the variables, though, is what I had started here. So if you're not sure how your charges and your force are related, and your separation distance and your force are related, you can plug ones into your equation and then change whatever thing it's asking you about, right? If I want to double my charge, I would put a 2 here and see that how that affects my force. Just in general, your charges are directly proportional to your force. So if you double a charge, your force will double. Your separation distance is inversely related to your force, but not proportional because of the square. So if I double my separation distance, my force is going to go down by a quarter, right? Which you can see when you plug it in ones and then change it. So if I put a 2 here instead of a 1, it'll go down to a quarter of whatever your original force was. But my intention for this video is actually to go over how to use these, how to convert these units into their proper unit. So coulombs is your proper unit for charge, but we were given, for number 2, we were given it in microcoulombs. So we have to do some conversions there. Same thing, meters is our separation distance unit, and we need to convert that centimeters to meters. So if I'm going to pull out my variables, and you also actually need to be familiar with how this thing got charged. So a glass rod rubs against a silk cloth and gains a charge of negative 5.3 microcoulombs. So the glass rod now has a negative charge, but because of conservation of charge, right, that must mean that my silk has a positive 5.3 microcoulombs. So I'm going to put negative 5.3 microcoulombs for one of my charges and positive 5.3 microcoulombs for my other charge. And we can assume that these things were neutral before we rubbed them together and they were charged by friction. So the overall net charge of your objects is going to be the same, and if it's neutral, if one is negative, the other one must be positive by that same amount. So anyway, we want to have our unit in coulombs. So like our instructions say, if we are given a microcoulomb, we're just going to say times 10 to the negative 6 coulombs. So this will be positive 3.5 times 10 to the 6 coulombs, and centimeters to meters is move the decimal place twice. All right, so now that we have our variables in their proper unit, we can plug it into the equation. So our force is going to be equal to our constant, which is 9 times 10 to the 9th, times one of our charges, times our other charge. Ooh, excuse me, that's negative. All right. Divided by our separation distance. And even though our separation distance is squared in the equation, oftentimes students will not square their separation distance. So to prevent this from happening, I write out my separation distance twice to remind myself that this is separation distance is actually squared in the equation. When working with scientific notation, when you're multiplying, you're going to add the exponent. So you could plug this whole thing into your calculator, but be careful that you have parentheses around your numerator and around your denominator so that your calculator knows the order of operations to do. But frankly, I would do 9 times 5.3 times negative 5.3 separately, and then I would take care of my scientific notation. So times 10 to the 9, 9 plus negative 6 is 3, plus negative 6 is negative 3, and then I would multiply these two. I did not plug this into my calculator before starting this video, and I feel comfortable that you will be able to do that without me, but to reduce or to make you feel more comfortable, I guess, I would try and reduce my equation as much as possible before I plug it into my equation.